Hi, so me and Sophie are going to do kind of the same slot but talk about each of our independent research projects. So I am a PhD student, I'm in my second year of PhD at the moment, and my research is looking at prehistoric settlement population progression in Westray and Papua Westray. I'm doing that through a combination of radiocarbon dating with isotopic analysis. It's in association with SUERC and Glasgow University, and it's funded by HES. So my research, what does it entail? It's exploring the nature and extent of prehistoric settlement progression in Westray and Papua Westray through elements such as site continuity, population continuity, and the human-environmental relationship through things like diet and the use of animal remains. So why do we need to do this? Island sites are particularly at risk right now of coastal erosion and rising sea levels. And there are a number of sites that have already been damaged or lost due to the rising sea levels, and that's resulting in gaps in the chronological narrative. And Links of Noltland is one of those key sites. So I'll be doing that through a combination of radiocarbon dating, isotopic analysis, Bayesian modelling and predictive modelling in GIS. So the study area that I'm looking at is Westray and Papua Westray. So these are the most northwestern islands in Orkney, and they are often neglected in the Orcadian research despite them being rich in archaeology. There are 43 known sites on the prehistoric sites on the island at the moment, and they are primarily Neolithic and Norse Iron Age. This is kind of generally because that's where the focus of the research has been in Orcadian archaeology in these periods. There's little to no Mesolithic or Paleolithic records, but that brings into question of, is there none because there is none, or is there none because it's been left out in the research, or is there none because it has already been lost to the paleo coastal erosion and the rising sea levels? So that is something that kind of needs to be taken into account, and this research will look at that along with the kind of time and space elements that takes into consideration. So Links of Noltland is the key site on the study, and it's a multi-phase site. And what we'll be looking to do is apply the blueprint and the framework of the chronology at Links of Noltland to 5 other sites on Westray and Papua Westray. So the other sites are 4 sites on Westray and 1 in Papua Westray, and they are all sites that have shown evidence of multi-period use. So I'd say Links of Noltland is the key site. It's a really, really huge site on Westray. It's often referred to as Westray Scarabray. It's a 3-period site within 6 key areas of use. And the preservation level at the site is really incredible. Most of the structures, you can still see the full kind of size and extent of the structure. But that does bring in a lot of taphonomic issues that come into play with stone-built structures, such as the movement of materials for construction and reconstruction. And for that reason, we need to really make sure that for the sampling, we are locating contexts that are secure, so that we can make sure that that material has gone in fresh. But the point to really reiterate is how large Links of Noltland is. It's not a single-use, single-phase site. It's very complex, and there are issues that come into play because of that. So the radiocarbon dating is the first kind of method that we're using to relook at the chronology of the site. Radiocarbon dating allows us to measure the level of carbon in a sample and then calculate how long ago that sample died, or that organism died, to provide the date for when that occurred, and therefore the date of what it is in association with. There is legacy dates that have been produced for Orkney, and it is a really great database, but the material that is produced for that is mainly used from material on the mainland. There has been some work done on the islands and at Links of Noltland, but it's not as robust as it needs to be, and so because of that we really need to bring that legacy database together. So this research is looking at the existing dates and comparing them to the new samples that are being produced in order to assess the accuracy as well as fill in the gaps in the narrative. With the radiocarbon dates, they need to be calibrated in order to translate the date from radiocarbon age into the calendar age, and I'm using the OxCal program in order to do that, predominantly using the INCAL 13 calibration curve. So with Bayesian analysis, it does the radiocarbon dates we use, Bayesian analysis with the radiocarbon dates in order to better the accuracy of the dates that we are producing. Bayesian theorem, it does derive a posterior probability as a consequence of two prior circumstances, and that's the prior probability and the likelihood function. With the calibrated radiocarbon dates, they're essentially just probability distributions for the ages of the material that's being analysed. So for this, it's the likelihood function. And the prior archaeological information of the samples is things like the context where it was located within the stratigraphic matrix and the spatial associations. So we can use that prior information in order to inform the radiocarbon dates to produce better accuracy. And that combines the archaeological knowledge with scientific testing to produce better dates. I'm also using isotopic analysis. So the isotopic concentration of the samples, the bone samples that we're getting from the site, are going to be tested. So the stable isotopes are stored in the bone collagen of human and animal remains. However, different skeletal elements do have variable turnover rates. So the spongy trabecular bone is just a few years, whereas a hard cortical bone, that's stored for kind of 10 to 15 years, depending on the age of the sample, the species, and also the skeletal element itself. And that does need to be considered when we are doing that testing. We also need to take into consideration the marine carbon level of the samples, and that's because of sheep on islands who feed on the seaweed. And that gives them a marine and a mixed marine and terrestrial diet rather than just the traditional terrestrial diet. And that isotopic signature is passed on to the humans through the carbon cycle, through diet, and that does warp the age ranges that we are getting from that. So there has been some work done on the marine reservoir effect at links of Noltland, and that will be built upon in my research in order to provide better produce the accuracy of the dates for the site. So collecting the samples for this research has primarily initially been done through data structure reports and the information that is at the HES archive. So I've gone through each of the reports, through each of the contexts, in order to identify what's already been sampled and dated, what could be retested and should be retested, and anything new that is being produced. From those, we've gone through each of the contexts in order to select the ones that are most appropriate. So from just around under 3,000 contexts, 72 were chosen as appropriate for testing. And then from that, the samples from the context were selected. So we were looking for the bone, either human or animal, but it did need to be hopefully to be articulated in situ in order to make sure that it is a secure context. And similarly with the charcoal material, need to be a significant level, and the placement of the sample within the context, and that context within the structure, had to be taken into consideration. So we're looking for things like earth activity and kiln activity. So over 31,000 small finds have been produced for the site over that kind of 10-year period of excavation, and that includes bone, charcoal, pottery, worked stone. And from that, I've had to go through each of them individually and located 151 that are suitable for radiocarbon dating and isotopic analysis for this research. So they just quickly go over the radiocarbon pre-treatment that is going through for the samples and for the isotopic sampling as well. So each of the bone samples are cut down to kind of an inch size, and they're soaked in an acid wash for a couple of days, and that's in order to break down the material and remove any contaminant material such as collagen. And then once that's done, the material is evaporated down to a kind of a 10 ml sample size, and that's freeze dried and sent over to the AMS. So the whole process kind of takes around 2 to 3 weeks for the pre-treatment, and then another kind of 2 to 3 weeks for the AMS mass spectrometry. And that will also provide the isotopic levels for the carbon, the nitrogen and the sulphur. So that whole dating process should, to get all the sampling done, take around 6 to 9 months. And once we've got that, we can just put that information straight into the chosen Bayesian model that is produced in order to get that chronology. So just kind of what comes next for me then is that sampling process, and then as touched briefly at the start, the GIS predictive modelling, which we'll be using to program in information such as the coastline recession, and also resource material around the islands, in order to look at areas where there may have been sites that have already been lost to coastal erosion, and also sites that just haven't been located yet, so that we can fill out that narrative even further. And as I am second year in my PhD research, there will be a lot of writing for me going forward. But yeah, that's the research that I'm doing on Western Papua Westry just now. So thank you.